In this video, today we will be demonstrating tuple, which is an immutable data type. So let's open Python and we will first declare an empty tuple. So let's write tt equals to, we can use the function tuple. If we write type tt, it will tell us that it is tuple. Also, we can declare in this way. So this is also another way of declaring a tuple. Can we insert some numbers in a tuple? Definitely we can do it. So we can write down tt equals to say 1000, 2000, 3000. So this is a tuple which is having length 3, but since tuple is immutable, we cannot write down like this. If we try to add another element, isn't it? Or rather, if we see the built-in functions, we'll see that tuple has only two built-in functions. One is index and another is count. So how it actually works is, if I try to find the total count of a particular number, say 1000, it will return me 1. And if I want to find the index of 2000, suppose if I write index, so index value, index, we have to give the value. So it will tell me that 2000, the number 2000 that is there in the tuple is having an index value of 1. And now, after saying this, if I try to reassign some elements of the tuple with the help of an assignment operator, we'll see that it is not possible. For example, if I use the index, it is telling me 1000, but if I try to initialize it with the help of assignment operator, we'll get an error. Okay, because tuple is immutable, it doesn't support item assignment. By saying this, we still can reassign. How we can reassign? We can actually write down like this: tt equals to tt plus 1000, like this. So now we will see that it is added in the tuple. So we'll use this concept to add say 100 more random numbers between 600 and 6000. So for that we can import the random module. For we can write down like this: import random. So after importing random, we can use this random module like this: for I in range 100. Since we want to add 100 more numbers, we can write down tt equals to tt plus. Now here we have to write down this, and before that we have to write random dot rand int. It's an integer, so we'll have to write the range 600 to 6000. So this completes the picture. So now what is happening is, if I write tt, I'll see that it has total 104 elements now, because we already had four elements or 4 numbers in the tuple. Now what we'll do is, we'll pass this tuple to a user-defined function, and we'll try to split the tuple in 2 different parts. Okay, and this splitting of the tuple will be done randomly, and we'll be displaying both the parts. Okay, so let's try that option, because we know that if I write tt and if I write down 4 colon, it will display everything, all the tuples, starting from the index 4 to rest of the numbers. So it will start from 4877 and it will display till 1111 all the numbers. Okay, so we are exactly trying to do this thing, but we'll display both the parts. That means in this case the function will display both the splits, and the splitting will happen randomly. Since we have already imported random globally, so we don't require to import it again in the function. So we write a function df, and we name the function as split tuple, and it takes a parameter. So tt will be passed to s. Now it will be randomly splitting. So we require to find the length of this tuple, and we can store it somewhere. So we can write n equals to length of s. So it stores the number whatever is passed to s, which is the parameter of this function. Now when I'm splitting, suppose I'm splitting in a random way, so I may use a random number generator. So I can write n1 equals to random dot rand int. Now I'll be taking two numbers. The least number can be the 0. That is, if I actually get 0 there, so we all know that it will actually give the entire tuple in one split, and the other split it will give nothing. So the second one, the b will be, if I give length of the tuple, suppose this is 104. So how many numbers we have? So if I write 104, it will take both the numbers. Now it can take 104 also, but in this case we don't have 104 as an index. We have 103 as an index, so it is one less than the length. So it should be n minus 1. So that is possible. So that is stored in n1. Now the only thing that we have to do is, suppose whatever is n1, we can just print the tuples. So first it will take, we'll start from, if it is splitting at n1, so we don't know what is n1, so we'll take 0 colon n1 as the first. So it has to be the index of the s. Okay, so s is the tuple in our case. So this is fine, and the next one will be print s, and we'll take n1 and colon, nothing else, because it should print the rest. So let's try. We'll run this function split tuple tp, and what we do is we take tt. We can see that here it has splitted in these two halves. Okay, this is the first one, and this is the second one. Now by looking at this, can we guess what was actually stored in n1? So we can see that n1 actually, what is the length of this one? See, 1 2 3 4 5 6 7 8 9 10 and 11. So if suppose if I write here 11, then what will happen? It is actually, it is printing from 0 to 11. Okay, so if I write 0 to 11, that means it is taking all these numbers. So it is not going to print the 11th one, isn't it? Because it is starting from 0 0 1 2 3 4 5 6 7 8 9 10, and this is 11. So here we can see that it is printing, sorry, it should be taken from here, because this was the splitted one. So 1 2 3 4 5 6 7 8 9 10 11. So we can see that it is printing till this much. So we can just slightly modify this function a little bit, and we can display one more value here. We can just write print in one, and we can run the function again, because it will again show me a different split. So you can see that it is splitted in 92. So if it is 92, so the rest is being displayed here. Total length was 104. So here again 12 should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let's run it again. So again it will be splitted in another two different ways. So here 43. So you can see that the two divisions. So every time we run this function, it is actually splitting the tuple in two halves in a random fashion. So let us try to do one thing. We'll write another function that accepts this single tuple, and it will find the sum of the odd elements and the even elements. It is actually very easy, because this is our tuple and we are writing a function so that finds the sum of odd elements and the even elements. We can write another function like this: sum of odd and even. SOE, sum of odd and even. So it takes a tuple, so we can write, it will take a parameter, and here we'll be writing sum of odd equals to 0, sum of even equals to 0. So this will be incremented. So since I am actually having a tuple which is passed to the parameter q, so I have to traverse the tuple. So I write for I in q. Then I should actually find out whether I is odd or even. So I can write down if I modulus 2 is equals to 0. So if it is 0 means it is a even number. So we should write sum of e plus equals to I, else it should be an odd number. So we'll be writing sum of odd plus equals to I. So if I write sum of odd and even, if I run the function, okay, here what we have to do again, we have to print it, isn't it? Otherwise we'll not be able to understand that what is being printed. So at the end of the for loop, I should print sum of odd, sumo, sum sumo, and print sume. So now I will call the function sum of odd even, taking tt as a parameter, passing tt as a parameter, and we get this thing. So sum of the odd numbers and the sum of the even numbers are displayed. So I will ask you to find out whether it is true or false. So you can see the entire tuple here, or you can see the tuple here, actually the actual tuple. So you can find out, you can take a screenshot of this one and you can add individual elements. You can add individual elements of this tuple, and you know that which one is odd and which one is even. These are all even numbers, and this is an odd number. So you first take all the odd numbers, add it in a calculator, and you definitely see that it will be same. The third thing that we can do is swapping of tuples. Okay, it is very easy. Suppose we have two tuples. One is this tuple and the other is maybe a tuple. So suppose if I have tt as a tuple, okay, and if I write down tt1, okay, tt1, if I take a smaller tuple, so I take tt And if I write 10 to 20, so it's a small portion of the tuple which is stored in tt1. Okay, we have done a shallow copy, so you can see that tt1 is this one from here to 3028 here. So 3, 4, 5, 6, 7, 8, 9, 10. So 10 elements are there in tt1 only. So I will be passing both tt1 and tt, and I will try to swap and I will print there. Both are global. So we'll write df swp swap a comma b, two tuples a comma b. So here, if I were to swap, suppose if I first print a and print b, so I get the initial value of the tuples. Now what I'm doing is I'm swapping. Okay, so for swapping we only write a comma b equals to b comma a. So this will actually swap, and again if I write print a and b, I'll be seeing that the new elements, the new values of the tuple. So if I call the function with tt comma tt1, we see that this is tt. I hope this is tt, and this is tt1. Now this is tt1. Sorry, this is the new tt which is swapped because it is printing a and this is printing b. So it should be the uh, the new tt1 because the original tt1 was this one only. So now we can see that the elements are actually swapped. This can actually swap anything, not only tuple. Suppose if I have two numbers, say x equals to 9 and y equals to 77. So if I call this function, with the help of x and y, then also we'll see that it is swapped. So you can see that first x is 9 which is printed, y was 77, it is printed. Now x has become 77 and y has become 9. So this video actually demonstrates a lot of things regarding tuple. Although tuple is a immutable data type, we can see that we can actually work with the tuple in many different ways. We can expect that from many different angles there can be a question. Also, not to forget about the conversion. For example, if I have tt equals to list tt written, then you can expect that tt, which was a tuple, is now a list. So now we can actually, since it is the list, we can do one thing. We can actually sort it, tt dot sort. So we can sort the list, and we'll see that the list is sorted. Now what I can do is I can take it back to a tuple. I can write down tt equals to tuple tt, and now you can see that you get back the tuple. So now that we have a very nice idea that how you can rearrange elements in a tuple, and you can actually see that whether there are any elements repeated because they are all sorted. We can till now I can't see whether any elements are actually repeated. Yes, one element is repeated, 4086. So there may be more, but it's a very small number of cases, so it could not happen also. But if you take a shorter range, and then chances of repetitions are more. So this comes to the end of the video. I hope you have enjoyed it, and we will try all this whatever we have just done. In case you have any question, you can always write in the comment section, and we'll try to solve your query. So see you in the next video. Goodbye.